All right, we are beginning what we call Chapter 5. It's Unit 3B or Chapter 7. It's just a number, so don't get caught up in it. It's not the end of the world. But what we are beginning is we are starting Chapter 5 for us, Chapter 5, in which we are talking about chemical reactions. Now, this is Section 5.1. When we talk about chemical reactions, we have to talk about chemical equations. What is a chemical equation and what is in a chemical equation? So a lot of you have been talking about, well, when do we get to blow stuff up? That'll be really cool when we get to blow stuff up. Well, chemistry is like cooking. You have to know your equipment. You have to know your ingredients. You have to be able to understand a recipe. Then you have to make a recipe. Well, we've worked with our equipment. We've just got done understanding our ingredients, and now we're going to start working on writing recipes and reading recipes so that we can start making stuff. So this is how we do it. A chemical equation is just like a recipe card. All right? It's going to tell you how much of each substance we need and what it's going to make. So in a chemical reaction, we have reactants and we have products. And the reactants are the things that are reacting, and the products are the things that are being produced. Again, one more time. The reactants are the things that are undergoing change or reacting. They are to what we call the left of the arrow. And the products is what's being produced. That's right of the arrow. Now, anytime you see an arrow means a reaction. I'm going to abbreviate reaction from here on out with RXN. So we have reactants and we have products. Now, we represent reactions with chemical equations. So we have reactants, arrow, products. For example, the burning of charcoal would look like this. Well, charcoal, guys, is just pure solid carbon. Anytime you burn something in the air, you're adding oxygen to it, and it's going to look like this. We're taking carbon plus oxygen, and we're going to get carbon dioxide. Now, what are our two reactants? Our two reactants, we combine it together, were carbon and oxygen. You can see here we have the arrow, which means we have a chemical reaction taking place. And then our product was just one product, carbon dioxide. Now if we write that in symbols, we have C plus O2 yields CO2. So that is a chemical reaction. Now, that is our recipe. This is how our recipe works. We're going to use this all the time. So let's review real quick and then we're done here. We've talked about anytime a chemical reaction occurs, it's going to obey the conservation of mass. So what does that mean? We're going to have the same exact weight in our reactants as we do in our products. You guys have done a lab on this where you took the Erlenmeyer flask. You remember you slid a baby test tube in there with two chemicals. You turned them upside down. You saw a reaction, then you weighed it. You weighed it before, you weighed it after. The weight was the same. That's because the conservation of mass is taking place. Now, if we look at the conservation of mass on an atomic level, what we have here is we have to have the same number of elements in the reactants on the left side as we do on the right side. So even though we have this undergoing a reaction here, we have our reactants, we have our products. But we have to have the same number of elements on each side. So if we count our H's, we have 1, 2, 3, 4 H's on the left, and here we have 1, 2, 3, 4 H's on the right. So we're good there. And if we go ahead and we look at oxygen, we have 1, 2 oxygens on the left, and 1, 2 oxygens on the right. And that is where we're going to go here with the next couple sections. We're going to do something called balancing equations, which helps us make sure that we have the same amount of elements on the left as we do on the right, because we have to obey the conservation of mass. So remember, we have reactants on the left, products on the right, and anytime we have an arrow, that means we have a chemical reaction. This is G.K. Clinton. I'm signing out.